Hello, it's Keith here, and this is lesson 50 of the platform-specific series of my Z80 programming tutorials. We're going to be going back to the MSX this time, specifically the MSX2. Now, we've looked at the bitmap graphics in the past, and we've used the regular 16-color mode, but that's not really doing the MSX2 justice because it actually has some more powerful modes that may be interesting to you if you're trying to create high-resolution applications like graphics programs, graphics editing programs, or desktop publishing. Any basic office kind of tools where you're not trying to do fast graphics, you're trying to do a lot of detail, or maybe just for things like loading screens where you don't need to move things quickly and you just want very detailed images. You see, the MSX2 actually has a variety of other modes which are far more powerful but use more memory. So we can have 4 colors at high resolution, 16 colors at high resolution, 256 colors at the regular resolution, that's 256 by 192, and we can even have on the MSX2 Plus this YJK mode, which allows for around 20,000 colours, so nearly a true colour mode. Now, as well as this, we can also interlace the screen. This is where, of course, every alternate line is changed every other refresh of the screen, and this will effectively double the vertical resolution. So we can double the horizontal resolution with the HighRes graphics modes, and we can double the vertical resolution with the interlace modes. But of course, these will potentially use a lot more memory, especially if we're using 512 by 192 interlaced in 16 colours. The 256 colour modes can't be done at 512 pixels wide, only 256, but that's still an awful lot for an 8-bit system. Now, all of these are very simple to use actually. All we need to do is change the initialization data that we pass to the VDP and it will turn on these modes. And of course, we need to have data to actually provide to the graphics hardware that is going to do what we want. So we're going to look at that today. I'm going to show you some examples. I'm going to discuss the settings we have to change, and I'm going to show you how I've created valid files with my Sprite editor, which is, as I say every time, free and open source. So if it helps you, please download it. If you need something adding to it, go ahead and add it. So hopefully it will be some use to you if you're interested in this kind of thing. Okay, so let's actually have a look at the code and see some examples. So we're going to be using 2 files today, and these have some options that allow us to toggle between different modes. So we've got this high-res file here, and we've got this 256 color file here. We're going to start with the high resolution file, and we're going to just compile here with no settings set. And this will turn on the 16 color high-res mode, and we do that by setting the mode register 0 here to the low nibble as 1010. That's all we need to do, just change that one setting. And if I compile this here and run it, you'll see we've got our Chibico character and we've got 16 colors on the screen. You can tell from this corruption up here. And so we've effectively doubled our horizontal resolution. Now, the disadvantage of this, of course, is that although we've doubled our resolution, we've also doubled the size of our screen. So we're now using a 48K screen rather than our previous 24K one. So we're going to have to shift twice as much data around to draw a screen. So probably not so much used for action gaming, but maybe for strategy and things. It will be quite useful for those. But anyway, as I say, it's certainly worth you knowing about. Now, as always, we can export these kind of files with Sprite editor. I just exported this. The colors are different because I haven't defined the correct palette, but that can certainly be done there. So that's the first mode. Now, if I turn on this interlacing option here, now you can see what's happened is every other line is kind of missed out here. So the screen pixels have been sort of split and are only covering every other line. And I've done this intentionally incorrectly. I've used the old sprite data and I've drawn the screen with it. Now, to enable the interlaced mode, we need to change our screen settings once again. We just need to set these 2 bits here of register 9 to 1, and that will turn the interlacing on. As well as that, we also set the pattern table. We just need to make a slight change here. I've had to add 32 to the base pattern table. You see, when we enable interlacing mode, we're actually using 2 pages. Now, the video memory of the MSX works in pages, and each page is 256 lines. Not all of them are visible, but they are 256 lines. When we interlace, the second page will become the alternate lines. And what this means is we need to draw our sprite twice. We need to draw it first in the XY position we want, and then we need to draw an alternate version with the alternate lines 256 pixels down from the first position, and they will fill in those blank lines that you saw in the previous example. And the way I created the files for this example is I just used Sprite editor here, and we've got a interlace odd fields function here which will squash up the character. I then exported it twice. All of the exporting for today's example is done with this option here, Save Raw MSX2 Bitmap. This will do 4 to 256 colors. So I exported two separate files. You can see them somewhere down here. Here they are. So here's the two files, and then we draw it at the base location, 50 down, and then the base location in the second page in 256 added to that Y position. And now if I compile the version with this enabled, I just need to turn this test on here. You can now see our character is half as tall, but it is actually twice as detailed, and there are no missing lines in this very small character here. So that's how we can use the interlacing. Now, as I say, those modes use a lot of memory. The regular mode 512 pixels wide would be using 48K, and when we interlace it, it will be doubling up again. So you're going to be using a lot of memory there. Now, if you want a higher resolution, but you don't need the colors, you can enable the 4-color mode. And again, we can export this with my HighRes Sprite editor if I just run this. So you can see now we've only got these shades of green on the screen, but you know, this would be ideal for your desktop publishing application, because as I say, if you just need the detail, you don't need the color, then it's going to be perfect for you. And this won't be using any extra memory. So if you need speed as well, or if you just don't want to, or if you need the paging options for some reason, like if you're using a desktop publishing application, maybe you want that extra space for object sprites that you may want to drop in on the page, or for multiple pages or something. So it's definitely worth knowing about if you just need detail and not color. So that's another option there. And again, very easy to turn on. We just go to our settings here and we set these bits here. We just 1000 here in the bottom nibble of the register 0 here. And this of course does work with interlacing as well. So that's the basic modes. They're just slight extensions of what we've seen in the past, basically just higher resolution versions. Now we're going to move on to the 256 color mode. Now this is always 256 pixels wide, it can't do 512, it can do interlacing, though we're not going to show it today. If you wanted to use it, it would just be the same. Now what I've done here is I've created this sample image here, which is my V9K, and you can see we've got some nice colours here. This is the later version of HighRes Sprite Editor, which I've extended to support 256 colours, as you can see here. Now what I've done here is I've actually loaded in the MSX palette, because it's a very special palette in this mode. I'll just show you here. Now all you need to do to enable this palette is select this option here and then load in your file. But this mode actually is very different to the other modes. All of the other modes are just in linear pixel format, where every consecutive pixel is defined by consecutive bits within the byte. And these colours would be selected from the palette as normal. So they're all basically the same, just different iterations of the same theory. But the 256 colour mode is very different. Effectively, every single pixel is defining its own colour in RGB format. Now it uses 3 bits for the red component, the top 3, the middle 3 do green, and the bottom 2 do the blue component, so there's only 2 bits left for the blue component. Effectively the same as the enterprise format, ironically, although the bits are in a different order. Which is why, if you see my HighRes Sprite Editor, the palette option, if we go to Tool and Palette, says MSX and Enterprise, because the exporter will deal with the format, but the colours we would have to choose from are the same. And all you need to do is go to File, Save MSX 256 Colour. You just need to make sure 256 Colour is selected here, because if you've only got 4 colour selected, it's going to export it in 4 colour mode. So that's how I've exported the file for today. The rest of the code, very straightforward. I've got some other options disabled there, we're going to see later, but to just enable the 256 colour mode, all we need to do is set our mode 0 register here in this format as shown here, so 1110 here in the bottom nibble, and that's all we need to do different to enable the 256 colour mode on the MSX2. So let's fire it up, and there we've got a nice 256 colour image. Doesn't look too bad at all. Now it would look better if I'd used some dithering, but I've been fairly crude in this example. I just wanted to do a very quick look at how it worked. Okay, so that's what the limit of the MSX2 effectively is. But the MSX2 Plus has a few more even powerful modes. Now one of these allows for 20,000 colours, and rather strangely it does it without using any extra memory. Now that sounds impossible, doesn't it? But they've done a trick. Now if you're familiar with graphics from video hardware and the way they compress video, what they often do is they take the black and white information and they store that at a higher resolution than the color information. So effectively you've got a black and white image and then some encoded color information that's much lower resolution, and then the two are combined together, and that gives to the human eye the impression of a lot of colors at good detail, but they've saved a lot of memory in the process, and they've used that saving to allow the same resolution in the same amount of memory but with a lot more colors. Now unfortunately it's rather tricky to create the data, but you'll be pleased to hear Accurate Sprite Editor can do it if you require it to. Again, we just load in a file. Now I've loaded in this image here. Now I do have to be honest here, Accurate Sprite Editor is unfortunately only a 256 color image editor. So what I've done is I've converted this to a GIF and imported it with dithering. So what you would have to do is effectively export each file separately to be able to take full benefit of the high color abilities of the system. I'm afraid Accurate Sprite Editor would be an awful lot of work to convert it to a true color image editor, so I can't justify it for just the MSX, but it's at least some use, because as I say, if you had 5 different images on the screen, you could have a separate 256 colors for each, and then use this YJK or YJKA format to show them onto the screen. And all you need to do is go here, File, and you've got these two options here, YJK and YJKA or YAE format, which we'll look at separately in just a moment. So the first one is YJK, the 20,000 color mode, or just slightly less. The YJKA has fewer. We'll look at that in just a moment. So how does this format work? Well, as I say, it's tricky. Well, let's actually just fire it up first. Maybe it'll be a bit clearer if we actually run the code. So I'll just enable this YJK option here, and this will set this bit here. This is something we don't usually need to use, but we do if we want this MSX2 Plus mode, and it only works on the MSX2 Plus. It won't work on the MSX2. So here's our image, and you can see it looks a lot better now. You can also see there's this weird graying out of the background here. So let's have a look. Now what I'm going to do is I'm going to do something a little bit screwy just to prove a point. So here's the correct image file that I need to show in YJK mode, but I'm going to show the totally wrong image file because it's going to cause some corruption, and I think that corruption is going to make it clearer what's going on. So we've made quite a mess there, haven't we? Now, I don't know if you can see, but if you look horizontally, 4 consecutive pixels will always have basically the same color. And that is a kind of a clue to what's going on here. Now, the way that this format works is, as I say, it's basically splitting the black and white information and the color information up separately. And the way it does it is it defines the black and white information using 5 bits of each pixel. The color information, which is made up of 2 components, J and K, and these are encoded, they're calculated from the original red, green and blue. And those J and K components are 6 bits, but they're split into 2 3-bit parts, and they're stored in 4 consecutive pixels. So each group of 4 pixels will have a separate grayscale component for each pixel, but will share a common color component, which is made up by calculating from J and K, each of which is 6 bits, split into 3 bits and stored in those 4 consecutive pixels. So P1 here would be using these 5 bits of the grayscale, and P2 would be using these 5, and these 5, and these 5, but they would all be sharing the same color information, so they would all be effectively different shades of the same color. Don't know if that makes any sense, but I can give you a few more demonstrations of this. So we're transferring our image to the screen in exactly the same way as we always have in the past. Now what we can do here is when we load in from our sprite, we can artificially remove the color information, and that will just show the grayscale part. So that's what I'm going to do now. So I'm effectively removing the bottom 3 bits. As I said, the 3 bits of each will make up the colors, so I'm removing this part. And now you can see we've got this grayscale image here. So that's how it's doing it. It's effectively, the colors have been removed, so all you've got left is the grayscale, and that's why the vast majority of the background is grayscale here. Now alternatively, so what I've done here is I've kept the color information intact, but I've forced the top grayscale information to be always a mid color, and let's see what effect this has had now. Now you can see basically all we've got left is the color information, and you can see that the color information is effectively very blocky. It didn't look that blocky before though, because the human eye sees the grayscale effect more significantly than the colors, and that's how we are able to compress things. And this is what was used to be done in MPEG-2, and it's still done to a great deal in the modern compression codecs today. It's just the modern ones are so much more advanced, it's not as noticeable. I remember back in the early days I had an old MPEG-2 decoder card, and if there was a scene where the screen was very red or very blue, like in a submarine film or something, then it would look absolutely terrible, because they were doing this kind of compression internally within the card to get the video to the screen. So it's very, very common, this kind of trick. It's just possibly something you haven't needed to know about in the past. Now, how do we calculate these? Well, there's formulas, and these are the formulas. I'm not going to go into them. Basically, you will need to, if you want to generate these, to take your red, green and blue components. You will need to calculate your grayscale component with this formula, and then your K and J. And the K and J parts are signed. You will need to convert them and then store them in the bits here. Now, if you want to know what I'm doing, this is the formula I'm using, and it seems to work. I'm not saying it's perfect, but it certainly seems to work for me. And then I'm taking the top 5 bits of Y and the 6 bits of J and K. So that is how I've created the file. This is C# code here. So as I say though, if you want to create a valid file, you can use my Accu editor, but if you want to do a better job, for example using really true color, because as I say, that's not something I can do at the moment. Now if people really want to see true color, then let me know and I'll make a converter for it, but I'm pretty sure there are probably converters out there already. Really, I always try to add these things to Accu editor for a bit of fun and experience, but I'm pretty certain there's going to be better converters out there that can do directly converting bitmaps, rather than loading into my 256 color editor and losing some of the color detail. Anyway though, as I say, I just wanted to play around a little bit. So that's how we can do things, but there is a few major problems with this mode. Now firstly, of course, is we've got this clumping of colors. You know, 4 pixels are always sharing the same color, so not very good if you were trying to show our Chibico sprite on the screen as well. But there's another problem, you see, because 4 consecutive pixels are sharing the same color information. If I change my code and try and show my sprite from memory at X position 50, and I just need to disable my test code here so we can see things properly to start with. So what I've done is I've moved the image 2 pixels to the right. Now, if you can think about it, something's going to go wrong. Now what is effectively has happened is the colors kind of look like they've swapped around here. Well, why is that? Well, if you remember, 4 pixels are sharing the same color information here. So by moving my sprite 2 pixels, I've effectively swapped the J and K components here. And boy, is it made a mess. It kind of looks like my channels aren't focused and they're inverted. So that's going to be a rather major problem. Now, it wouldn't be such a problem if you were using a static background picture, or if you were just showing a loading screen. But if you wanted to have a game and have some characters like fighting over the top of this, or some text, it's going to get quite difficult for you. Now, there is fortunately an alternative mode. Now, as well as the YJK mode, there's another one which is YJK plus YAE. What's this mean? Well, the A is attributes. We can effectively have some of the benefits of YJK with a 16 color palette. So we lose some of our colors. Rather than 19,000 colors, we only have 12,000, but that's still an awful lot and you're not going to notice much difference. But the benefit is we now have our old 16 color palette that we can add as well. Well, something's obviously changed there because we're still using the same amount of memory, and what has happened is we've gone from our 5 bits we used before to just 4 bits. Effectively, we've just stripped away one of the bits from the bit 3 position. When that's a 0, we're using the basically same formulas as we were before for our true color image. But when it's a 1, the top 4 bits now define the paletized color as it would in a conventional mode. Now, let's see that in action. So if I fire this up again, so if I just correct my X position here and change it to 48, fire this up again. Well, you can see our image basically looks the same. It's hardly changed. It may be a little bit cruder up here, but not much different. But now if you look at this part here, you can see it looks almost the same as it did before. These all look like perfectly crisp 16 colour information, and you can see there's no sharing of the colours between the pixels. This is effectively giving us the benefits of both modes, if you will. We can now have our 16 colours and our very detailed colours as well. Of course, we're still going to be using a lot of memory, so it's still going to be slower than a true 16 colour mode. But, you know, as I say, there's going to be plenty of games that this could be useful for, so it might be something that's going to be benefiting you. It's also very easy to use. All we need to do for both of these is, if we want YJK, all we need to do is set the register 25, which is an MSX2 Plus register. We just need to set bit 3 to 1 here, and we just need to set bits 3 and 4 here to 1 to turn the attributes on, YAE as it's called. And as always, if you want to export this YAE mode or the YJK with attributes, if you just go to the MSX menu here, select File, and you've got the option just here. So you've got both options as added bonuses here. So if that's what you want to do, you can certainly do that. So there we go. That's really all of the more advanced MSX modes that I know of that you might want to use. As I say, they're not going to be the best choice for your gaming. You're going to want to stick to the 16 colour mode for the speed, I think, in most cases, because if you think about it, Chibi Akuma's was only a 16 colour game and it wasn't massively fast. So if you doubled the amount of memory, then you would have halved the speed. But, you know, for a slower game like a strategy game, it might be very, very appropriate. That's all we're going to be covering today anyway. Hope you found this interesting. Thanks for watching, and goodbye.